Hello everyone, this is Mukarram from Group 376 and today I will be presenting our Milestone 2 update for our project porting LLMs to mobile and connecting it to other mobile applications. This project focuses on creating a fully functional mobile chatbot that runs completely offline and using a lightweight model. Today, I will walk you through our progress, key features, learnings, and challenges we face along the way. Now, let us see the working prototype. We have successfully built a working prototype of our chatbot app. The app runs completely offline and uses a 4-bit quantized version of Tiny Llama model, and it is integrated with React Native on the front end. And we used llama.rn. This is a framework which we have used to connect to our model for on-device inference. The chatbot responds very efficiently. For example, if we give a prompt like open YouTube, then it will automatically opens the YouTube for us. And one of the other feature is adding a calendar event. Uh, in this demo, we are adding a event in the calendar app where we specify the date and time of event and what name we want to give to that event, and the model will parse the important details like information regarding a event like date, time, and the name of the event, and it will redirect us to the uh, calendar app where we will need to save or cancel the event which we have given to the model. Now, core functionalities. Our project is more likely like a virtual assistant, uh, which differs from a chatbot. Like it can open app for us, and it can add a calendar event, and it can also set an alarm for us. We can also call to any person in our contacts using this by just giving a prompt to this chatbot. So our app follows a modular structure. The React Native frontend communicates with the llama.rn to run the tiny llama model. And this model is bundled in the app using GGUF format. This is a file format extension for system level tasks like launching apps or making calls. We built native modules in Java or Kotlin and connected them via React Native Bridge to run a specific task. Like while using the functionality of app launching, we have used a native module of React Native uh, where we wrote usable functions for model inference, prompt formatting, and app launching. The logic for Tiny Llama runs in a separate file, and all the device features are handled through custom native modules. Like I said, native module bridge in app launching and other Kotlin modules are used in alarm clock setup and etc. Now let us briefly look at the technical implementations of these features. For calendar event handling, the handler function takes a user input like it takes the input from the user and extract date, time, and even details from the user input using Tiny Llama and returns a structured JSON format for alarms or calendar events. This is further uh, implemented using native modules. And for open app function, parses a app name from the command like open YouTube and launches the app using native modules with fallback package support. Like if there are no matches in the defined JSON, uh, then it will use the default mobile app mobile app implementation of that particular application. And for alarm setup, it extracts the day and time in 24 hours format from the user and triggers a local alarm via native code. Similarly, for call features, the model extracts phone number from the natural language and initiates a direct call using a native module. Basically, the model is used for parsing and extracting the useful information from the user prompt, and this JSON format is further utilized by native modules to further execute that uh, task. Major learnings during this project. This milestone helped us gain a deeper understanding of how language models can be deployed on mobile devices, and we also explored how to bridge native code with JavaScript in React Native using native modules. Managing large files like model weights inside an Android internal storage and debugging Java native inference related issues were also part of our learning. We have also learned integrating AI with device features effectively. Overall, we have learned how to integrate machine learning models with mobile UI and native features with efficient way. Architecture evolution. The changes we have made in the architecture that we used before in the first milestone, that firstly we thought to use the Termex approach, like using Termex for running Llama, but we replaced it with tighter llama.rn integration. We have also enhanced prompt parsing with custom logic, like we have enhanced the system prompt for the model to understand the prompt correctly, query correctly, and act accordingly in efficient manner. The challenges we encountered. One major challenge we faced was integrating a large language module with mobile app without crashing or exceeding memory limits. We had to experiment with quantization format like GGUF, and learned how to run models with llama.cpp and llama.rn effectively. Another challenge was copying large model and indexed files from assets to local internal storage and making them accessible at runtime. We have also faced the challenge while uh, parsing the query during offline natural language command parsing difficulties. Bridging React Native with Android's native features like alarm and app launching was also tricky, but we solved it using native modules and testing each case individually. We have chosen Tiny Llama because it offers a good balance between size, performance, and compatibility. It is much smaller than other models like Mistral and Llama 2 and can be quantized down to 4-bit without losing basic language understanding. This makes it suitable for mobile deployment, especially for apps that need to run offline. It also support it is also supported by Llama CPP and works smoothly with llama.rn, which made it easier to integrate with our React Native project. We have considered multiple small language models before finalizing Tiny Llama. Mistral 7 billion parameters was too large for mobile devices, and Phi 2 showed slower inference during testing, and GPT-2 small, it also struggled with understanding prompt effectively, while Distill GPT lacked proper community support and updates. Ultimately, Tiny Llama struck the right balance between size, speed, and offline performance, making it ideal for our use case. Our app still allows optional downloads for these models for future experimentations. Thank you.